So this question is basically a motion question. How much room? We're looking for distance. So we're thinking about x positions. In fact, always good to draw a picture when you approach any problem. So here we have a car that's going 55 miles per hour. And ultimately, this car is coming to a stop. So somewhere over here, the velocity is equal to 0. Maybe I'll make a little number line here. The question is, how much room does it need? So really, if we say, let's say the initial position is 0, we're interested in, so what is that final position? Other things that we know about this is simply that while the car is coming to a stop, the coefficient of friction is 0.9. So we don't know anything about time or acceleration. So as I said, this is basically a motion problem. So I'm going to make a motion data table. XO, XF, VO, VF, AT. So again, we can say that XO is equal to 0. XF is what we're trying to find out. The VO is 55 miles per hour, but we really need to convert that into meters per second. So you can do that by whatever method you choose. Sometimes Google works nicely. I can actually do this on my calculator. I can type in 55 miles per hour and just convert that to meters per second. It's 24.6, let's say, meters per second. So this is 24.6 meters per second. And it is coming to a stop, so the final velocity is 0. And those are the only things that we know for the motion data table. And that's not enough information. Somehow we need to get more information in order to use a motion equation. And that's going to come from this equation. Acceleration equals net force divided by mass. We're going to use an analysis of the forces to figure out what the acceleration is. We're talking about the acceleration in the x direction here. And of course, if you're going to do forces, you should draw a free body diagram. So for the car, we have Fg, and we have normal force. The ground pushing up is called normal force. Those forces are balanced because the car is not accelerating up or down in the y direction. It certainly has friction force acting on it. So I'm going to draw friction there. Actually, I'll put a negative sign because it's backward or to the left. Typically, we say that left is negative. I am not going to draw a forward force, and sometimes this confuses people, but if you're slamming on your brakes, the motor is not pushing your car forward anymore. In fact, nothing is pushing your car forward. You simply have velocity from the engine being used in the past, and now the brakes are reducing that velocity with that force of friction. So that's a complete picture there. And what we need to do is apply this to our acceleration in the x direction equation. But there's not a whole lot of information here, and that's what makes this problem tricky. But let's give it a try. Acceleration in the x direction, we have to add up all the forces in the x direction. Well, there's only one to add up, and that is negative friction, and then divided by mass. And so it seems as though maybe we are stuck. What else are we supposed to do? We don't know the friction force. We don't know the mass. Wasn't even given in this situation. So how are we supposed to do this? Well, don't give up, because what physicists will do is think of other equations that might apply to this situation and use the mathematical technique of substitution, hoping that eventually maybe some things that we don't know will cancel out, those variables will cancel out, and we'll get to a final answer. So I think the obvious thing to try here is this formula. Friction, maximum static friction, is equal to the coefficient of static friction times the normal force. That's helpful because we know that the normal force is 0.9, which means we're probably going to have to use that number. So what I'm going to do is I'm going to substitute this for this because they're equal to one another. That's going to give me acceleration in the x direction is equal to negative this coefficient of static friction times normal force divided by the mass. Does that give me a final answer? No, but it at least allows me to put one number into this. Coefficient of static friction is 0.9. So I'll put that number in. but I don't know the normal force, and I don't know the normal force because I don't know the mass. So here again, we're in this situation of what should we do to solve this problem. So let's go back and take a look at our picture here. And in our picture, we can see that the normal force is balancing the force of gravity. So normal force and force of gravity are the same thing. I could replace in this equation normal force with the force of gravity. And so let me do that on this other page here. So acceleration is equal to negative 0.9 times the force of gravity divided by the mass. Still, I'm not at an answer, but the reason I did that is because we do have an equation for the force of gravity. Again, the force of gravity, sometimes people think it's 9.8. It's not. It's mass times 9.8, m times g. And so where I have an Fg, I could replace it with an mg. And this, well, this is where the magic happens. So 0.9 times mg divided by m. Well, there's what we were looking for. We have a mass on the top of the fraction and a mass on the bottom of the fraction. So the mass cancels out. And acceleration is equal to negative 0.9 times 9.8. And that'll give us an acceleration number that we were looking for. So 0.9 times 9.8 is 8.82. The acceleration here is negative 8.82 meters per second squared. So now I can go back to my motion data table with that knowledge that acceleration is negative 8.82 meters per second squared, and I can figure out what the final position will be using the equation that doesn't have time in it. Vf squared equals Vo squared plus 2a xf minus xo. So we're going to do 0 squared equals the Vo squared, which is 24.6 squared, plus 2 times negative 8.82 times xf, which is what we're looking for, minus 0. So algebra would be 0 equals, I'm going to square 24.6, and that gives me 605.16. I'm going to multiply 2 times negative 8.82, and that gives me negative 17.64, and that is times xf. I'm going to add the 17.64 xf to both sides, and let me continue that over here. So that's going to give me positive 17.64 xf equals 605.16, and then I'll divide both sides by 17.64, and that should give us our final answer of 34.3 meters.